Welcome to all of you already in line, and a very, very warm welcome to the kick-off sessions of our webinar series, which will be with you in the next 2 weeks for the reason that our Interpack fair does not take place this year. So that's why we at BASF thought, hey, that's a cool idea to have some virtual webinars to show you some of our topics and to present them to you. So, and today we start with a very nice topic, and I'm very excited to have Andreas with me in the line, who I will introduce in a minute to you, to talk about the Circular Economy Program at BASF. And so just to give you a short idea of who we are, to whom do you talk to. So to start first with Andreas Kischerer here in the middle, our Director of Sustainability Strategy in BASF. We have to apologize that Victoria is not with us today due to the reason that she's in quarantine and is not able to join the webinar. But if you have any questions, you can also reach out to her via email, and the same also for Andreas after our session. My name is Nina. I'm in the communications department of the monomers division at BASF. And if you have any technical issues today, or if you have any questions, please feel free to reach out to me via the chat or the Q&A function, and I'm happy to help you with. And before we go into the content for today, I would like to start with some Webex housekeeping rules that you know what is going to happen here. So please provide your full name in this Webex session. Please do not appear as a dial-in user. We have put you all on mute, but anyhow, you can ask your question if you like to do that. You can use the chat functionality on the right-hand side of Webex, also the Q&A function, which is also on the right-hand side of Webex. You can raise your hand or ask a question mark or raise a question mark, and we can unmute you also. So you can directly speak to us if you like to do it that way. We will answer all questions after the session, so after the presentation of Andreas. We will ask you, or we would like to ask you, please turn off your video due to bandwidth reasons. And we also recommend you to use voice over IP connection, so the call using computer function. And please note, the session will be recorded so that we have the session available also for those interested colleagues who are not able to join today, but we will exclude the Q&A from the publication. So don't be afraid to ask your question. You can do that absolutely then after the presentation from Andreas. And if you are wondering why you just see yourself in this session, this is due to data protection reasons. So we are now in general about 80 colleagues, people in line. So you just see yourself, as mentioned, from a data protection point of view. And so to start, I think I can hand over to Andreas, and I wish you all colleagues in line, all people there, enjoy the session with Andreas.
Thanks a lot, Nina. And I also would appreciate if you go through the slides, because for our last session, I had some problems with the bandwidth, and it's better when you go with it. So I'm really happy that we can today discuss with you the circular economy. Why is BASF doing that? How that is done? And also I want to show you some of that examples. As circular economy is more than recycling, I want to go also beyond the packaging recycling and show a little bit more what we are doing in terms of circular economy and what is our definition and what is our program there. Since about 10 years now, meanwhile, we have a purpose. And the purpose of the company is we create chemistry for a sustainable future. And there you see that already in our purpose, the sustainability is included and drives then the whole development of the company. No doubt, we know that a lot of companies have a type of purpose and describe in the internet what they are doing with a lot of nice words, and that is normally not enough. So it's necessary that you have a purpose, but it's not enough. So therefore, you have to underpin, for the next slide, please, the purpose then with clear measures and also with targets, with quantitative targets, in order that everybody knows what are behind the purpose, what you do, what is intended with the purpose. And the key measures for the sustainability at BASF are three main key measures. One is that we want to decouple our CO2 emissions from the organic growth. And we do that with the carbon management program. So decouple CO2 emissions means that we do not want to increase our total CO2 emissions until 2030, but at the same time increase our sales and production volumes by nearly 50%, which means we have then a relative reduction of CO2 emissions per ton of product by about 30%. And that is a clear target that which is definitely tracked and is published, that target, and that will be measured every year how much our CO2 emissions are and how much our sales volumes are, and that will be tracked and checked also by the authorities. The second target, or the second measure that we have, is that we want to further increase our sales from accelerator products. So accelerator products that are our products who have a significant and over market average contribution to sustainability. And we know from all our products, we have about 60,000, which one contributes significantly to sustainability. And there we had, in the year 2019, we had about 15 billion sales from these type of products out of 56 billion total sales. And that share shall be increased to 22 billions into the year 2025, which means a 50% increase there. So we want to grow with our more sustainable, or the most sustainable products, more than with the average portfolio, which is in a clear steering of the portfolio. And that is not only a corporate number, so that number is broken down to each business unit. So in each business unit, they have targets, what type with how much with their sales should be in the accelerator category. The third one is that we want to speed up the transition to a circular economy. And there we have a circular economy program, which I later on show you a little bit more in detail. What is the parts of that program. And again, here we have quantitative targets. So that, for example, in the year 2025, we want to use 250 kilotons of recycled feedstock instead of fossil feedstock. And we want to double our sales of the circular products to 17 billion. So at the moment, you have about 8.5 billion sales of circular products, and that should be doubled until 2025. So you see that again here we want to have an average increase of this type of products, and again we want to steer the portfolio to more circular products. And again, every business unit has its specific targets, so that it's not something only from corporate to steer. That will be steered by a lot of business, or let's say all business units, and a lot of people in these business units. Okay, then the next slide, please. So there are the targets, but maybe you can ask, or somebody asked us, why do we engage there? And I think it's also absolutely clear that, especially in the last 5 to 10 years, the global plastic issue came up. That's in every media, and a lot of people think about how to solve that. And no doubt that what we see here is not the picture that we can afford to see in the future anymore. No doubt it was also not good having that in the past, but in the future we definitely have to do against that. We know that, for example, at the moment 8 million tons of plastic waste ends up in the ocean per year. No doubt that can be only estimation, but 8 million tons is really a huge number. We know also that, for example, only 80% of the global plastic waste is recycled. Vast majority of the plastic still is landfilled or dump site, or put to a dump site. Part of it is incinerated, and only a very small part is recycled. And as you know that the plastic normally does not decompose, there must be a solution there. And again, for some new businesses like electromobility, we see that in the year 2030, there are 1 million tons of batteries expected, used batteries, because the cars which are produced now with batteries, in up to 10 years, they start to be then end-of-life vehicles, or at least the battery is then at the end of its life, and then they also need to be recycled. And if you want to build up a recycling infrastructure that starts then in 2025, 2030, we have to build now the technologies and build now the plants that later on we can recycle then these materials and these batteries. Okay, then the next slide. So that is coming from the environmental topic, but there are also a lot of other stakeholders who are very interested in circular economy, and that the companies change circular economy. One is the markets. We know that a lot of our customers already have targets for either recyclability of their products or recycled content of the materials that we sell them. We know that from the packaging, mainly driven by legislation and by consumer preference, that they prefer much more recycled materials, and there is even a willingness to pay seen at the moment, because recycled plastic at the moment is traded with higher prices than fossil ones. In some businesses, we see that for automotive, that there are some companies who have targets with recycled materials already, and we see that for fabrics, building and construction and furniture, that all of our customers are looking for recycled content in their products, but normally with the same technical performance, because they need high performance products. Second, the legislators, especially here in Europe, they have put a lot of effort in the last years to drive the whole economy to a more circular economy. And we were really surprised about the speed last year, that although there was a corona crisis, that the speed of circular economy legislation did even accelerate instead of slow down. And if you look, for example, that since the 1st January this year, each European country has to pay about 800 euro per ton of non-recycled packaging plastic to the EU. That is a clear signal, and no doubt at the moment that is paid by the countries, but it's only a matter of time until that payment will be deducted then, and that the companies at the end of the day who bring the plastic into the market, or the packaging into the market, have to pay for it, which is then also a clear economic driver in order to a higher circularity. And we know that a lot of investors are looking much more on sustainable companies, and they are investing in sustainable companies instead in normal companies or average companies only, which then gives you a much better share price, and also some credits you can get easier with green funds, for example, where also BASF had last year the first green fund made. And that all leads to the assumption or the expectation that, let's say, the circular economy will grow stronger than the linear economy in the future, where then all of that additional sales and increase of business that you have seen beforehand, where we want to go, comes a big portion will come from the circular economy. So no doubt we can discuss about the speed of that. That's absolutely clear. But I think it's also clear that circular economy will grow stronger than the linear economy will do. But what is the definition, or what is circular economy? And there we took the definition of the Ellen MacArthur Foundation, where the target is described of the circular economy, not so much the way how to achieve that target. And the target is that we want to decouple the growth, so the economic growth and also the value growth and the well-being growth from a resource consumption. And that must be always keep in mind when we go for circular economy. Does that go for that target? And no doubt recycling can do that, but that is only one mean going for a circular economy. So recycling does go for that target, but it's not the only measure to go for that target. Circular economy is much more like repair, reuse, sharing, longevity, so that you can share then products and so on. That is much more, and also resource efficiency, having the same customer benefit with less raw material used. That's also something which goes into the direction that the growth from the resource consumption is decoupled. Okay, the next slide then, please. So how did we translate that then to our business? So we know from chemical industry that only a part of our products are products which are still exist after use. So think about vitamins. So vitamins which we are producing, they do not exist after the use anymore because they are eaten and digested. And the same thing for this for detergents, for example, which will be then in the wastewater treatment plant, will be biologically treated, and then they are gone to CO2 or and to biomass. So which means we have some products which are not existing after the use anymore. For those one, we have also possibilities for a circular economy when we are using, instead of fossil raw materials, using then circular feedstocks like biomass or recycled raw materials. For those products who still exist after the use, like plastics, yeah, we can, or catalysts, we have to define or will define new material cycles where we can use these materials again as raw materials for our new processes, and should be as close as possible to the chemical composition. And all of that need to be tackled with new business models, so that we don't be paid anymore for material, for kilogram of material, but much more for the use of the material. And there are some examples, like in some coatings where we are not paid anymore for a kilogram of coating, but a square meter of coated metal. And that is completely different, because then all of the business players have the target to use as much as possible material with the highest possible technical application. And with this type of business model, that counts also to decouple and the growth from the resource consumption. Okay, you will see some examples of that. And as I said before, we normally need quantitative targets, because only that what you can measure, you can later on also steer. And therefore, we already talked about this 70 billion circular economy sales in 2030, the 250,000 metric tons of recycled feedstock, and also a circular economy program, which exactly targets to detect and to develop these new business models in order to have new disruptive ideas, new ideas which directly go for a circularity. And there we have more than several dozens of projects already running. So they are sponsored by corporate, and which triggers then a lot of creative ideas within the company to come to really new solutions, as well from the technology, but mainly then looking for new business models. And that's a really interesting program. But no doubt we cannot talk about too much in detail about that. So the next slide, please. So the new material cycles. We have, that's the linear economy, where we come from a refinery with raw material. There we have then some naphtha with a steam cracker going to basic chemicals, basic building blocks. Then we make the polymer out of it. The polymers sent to our customers. They make the final product, and then very often it ends up in waste and goes either to the incineration or to landfill. So there are several possibilities for recycling. So the first one is the mechanical recycling that everybody of you know. If you have clean single material waste, for example, PET bottles coming from a deposit systems or coming from a waste collection, then you can go again for new PET. And that PET depends on where the raw material comes from, whether it's bottles or whether it's waste. Can be used then again to bottles. That is a very closed loop, and with deposit bottles that can be done. With PET coming out of the waste fraction, maybe from the yellow bag or from the separate collection system, you normally can go to another loop, maybe to fabrics and to fibers, and then it goes to the incineration. So it depends then on where the products, the raw material comes from, whether you can go for that loop. But you need that really clean stream. Otherwise, it's not possible to make a mechanical recycling. And the products are normally not virgin grade, only in exemption they are virgin grade. Another option is the chemical recycling, or we call it at BASF ChemCycling, via a pyrolysis. There you can really use mixed plastic waste. So plastic waste which is not only from one plastic material like PE, PP, or PET. So it can be a mixture of all of that. No doubt there are also some restrictions on the kind of mixtures, but in principle you can use mixtures. And then with a pyrolysis, which means heating up to 450 to 600 degrees without oxygen, then you are producing an oil out of it, out of the plastic. And that oil can be mixed together with the fossil naphtha and again then transformed via the steam cracker to polymers, and again can go to our customers. And the big advantage there is that as these polymers are then produced in the same plants as the fossil ones, they have really virgin grade technical performance, and can be used directly as a drop-in our customers. So they don't have to change anything because the technical performance is exactly the same. And that enables a lot of customers also to go for recycled materials, because if you are producing food grade products, medical grade products, or safety products like airbags or whatever, all of these products normally cannot go with mechanical recycling due to the technical reasons. So therefore with chemical recycling that's possible. And in between the mechanical recycling and the chemical recycling, there's a depolymerization, which is also a part of chemical recycling, where you also can use only specific polymers. So for example, polyurethane, polyamides, polystyrene, PET can be used, but not PE, not PP. And there you can make monomers again out of the polymer. But there again, you need single waste, single stream waste, single plastic waste streams. But as they again are produced in a chemical plant and are liquid in between, you can clean it up and you can then at the end of the day have also virgin grade products, also again as a drop-in solution for our customers. So there are the three different types of recycling, and we are convinced that the plastic waste stream is so large and so diverse that you need all of these three routes. And it's not enough to go only for chemical recycling or only for mechanical recycling. That is not enough if we want to tackle the big challenge with the plastic waste. We need all of this technology, and therefore we are advocating for a technology open legislation which allows all of them to develop their full scale. The next slide, please. That is now the example of mechanical recycling, our Petra brand that is done in South America, I think. where we have collected then PET bottles, and we have some applications for electrical connectors and motor tool power components, housing, appliance handles. So that is a quite normal mechanical recycling project that we are also doing, which is done no doubt from a lot of companies, and then there's a big let's say industry already doing that mechanical recycling. However, you need very clean waste streams, and let's say the easy low-hanging fruits are already earned worldwide. So next slide, please. That is a research project that we started some years ago, where we are using mattresses, used mattresses, and alone in Europe we have about 30 million mattresses every year, sorry. And they are collected normally with waste collectors, so they are already in a form where you have a significant amount, where you have some volumes already. And you know that some mattresses weigh about several kilograms, and very often they are made out of polyurethanes. No doubt there are also some fabrics in there, some springs in, and whatever. But we have to sort that into the polyurethanes and the rest. But the polyurethane that's then shredded, and on the right hand side you see that in the bottle, shredded polyurethane, and with the glycolysis you can transform that to a polyol, and with that polyol you can again make polyurethanes out of that. It's on a closed loop recycling at the moment. We can't make mattresses out of that, but another polyurethane which goes for house insulation. That is a research project where some demonstration plants are intended, and hopefully we can then also really contribute then to the mattress recycling in the near future. That were the new closing the loop. Another closing the loop is with the chemical recycling, where we can go then for recycled raw materials. We have two options. On the one hand, we have this recycled feedstock on the right hand side, which is recycled waste with our ChemCycling. There we are using post-consumer plastic waste from the packaging, or tires, then end of life cars, tires, and both of them can be used in different types of pyrolysis plants, and can make and then we can make oil out of that, and that oil can be fed again into our plants. No doubt in between we have to clean it up. That's clear, because you can't just use that oil as a feedstock, and you need to meet some specs and specifications of the steam cracker or the syngas plant, and therefore there is a cleaning step in between needed. But as it's a liquid, it is possible. It's quite a normal process, which also is done with fossil raw materials. Second option is then the biomass balance on the left-hand side. There we have from biomass wastes from the food industry or from agriculture. With this waste, we can make either biogas, or let's say our suppliers do either biogas or a bio-naphtha, which again can be fed into our existing Verbund system and mixed then with the fossil one, and with the mass balance allocated. Then I come later on to that. And then the fourth option is that we can have use biomass with a dedicated bio-based portfolio. So that is very often done with palm oil, with responsible sourced palm oil certificate, and that is mainly then for the detergents, but also for sugars. With sugars and so on, we can make bio-based materials which are produced in a separate plants, separate from the fossil ones, which is then not like the other ones, like the biomass balance and the ChemCycling. So we have a broad range of options, and we do all of them. The next slide, please. As I said before, if we are mixing either the biomass balance raw materials or the recycled raw material together with the feedstock, with the fossil feedstock, in order to use them in our production sites, which are normally using several millions of tons a year. You cannot replace within one day or 1 year the millions of tons fossil with a recycled one. So therefore, we starting mixing them up and allocating later on the recycled or the renewable content to the final product, depending on the customer demand. If all our customers demand that mass balance products, no doubt the fossil can go down to 0 and the recycled and renewable can go up to 100. As long as the market demand is, and of course also not the supply is as large as needed, then no doubt we need that allocation rule. And that is, by the way, completely similar to green electricity, where when you buy green electricity in your house, you may get the same electrons as before, maybe from the coal-fired power plant next to your house. But with that additional money that you bought green electricity, within your grid, the electricity provider builds some wind power or some photovoltaics and puts that electricity into the grid and allocates that additional electricity to you. And that is exactly the same process that we do with the mass balance, with the ChemCycling or the biomass balance, where when the customer wants bio-based materials, we are replacing the fossil one by renewable one or by recycled one, depending on what the customer wants. The more customer want these green products, the greener are our raw materials. The more customer want green electricity, the greener is the electricity net. And that is exactly the same process, the same idea that we are using with our mass balance approach. Okay, next slide, please. And that is done for biomass balance. No doubt, we have to discuss what type of biofuels is used. That's the next slide. So it requires normally no reformulation, because we have the technical performance of the product is the same, because they are produced in the same plants. It's available and for nearly all products, and for all products containing carbon and hydrogen, that is possible to do so, which enables us also to offer customers who never have thought that they can use recycled or bio-based materials for their production, because they are needing a high technical performance and high quantities. It's possible to offer them also then bio material coming with bio-based raw materials. And that saves fossil resources, that reduces greenhouse gases, and we make sure that the raw material coming from these bio-based materials are not in conflict with food, but they are sustainably sourced with certification, for example. So next slide, please. And these certifications that we have is either Red Cert or ICC, so that are EU-wide recognized standards also for biofuels, in order to make sure that the raw material is sustainably sourced. And the majority of the materials that we are using are deriving from wastes, so either from the food industry wastes or agricultural waste, or from paper or wood industry, biogas, and so on. So it comes from waste and is transformed then to high performance chemicals. And again, we have this greenhouse gas savings, which, because the biomass absorbs the carbon dioxide, and then it takes the carbon dioxide already away from the atmosphere, and then we have that material which is then carbon neutral. Okay, then next slide, please. The same thing for chemical recycling. There we are using, on the one hand, mixed plastic waste. We have a cooperation, meanwhile, with a Norwegian company, Quantafuel, who are using that mixed plastic waste coming from the separate collection in Denmark. And the plant is located in Denmark and produces then oil with the pyrolysis out of that plastic, and that oil we get from them and making new plastic out of it. The same what we are doing is with tires. So there are we are a cooperation with two companies, who are producing oil out of used tires, and that oil again can be fed into our production sites and make new plastic out of that. Okay, the next slide, please. That is the whole process where we have partners, and that's, by the way, something for circular economy that you always have to keep in mind. You can't close the circle alone. You always need a strong partnership. And here we have a strong partnership then with the collection of the and sorting of the plastic waste, so waste companies. Then we have these converters that are our direct suppliers of the oil, where we heavily support them with all our, because these plants, companies very often are small startups, but there they can benefit from all our technical and chemical know-how, and we're sending technicians to them to support them to run up their plants, start up their plants, and to run their plants. The oil comes to us, it needs to be clean, no doubt about that, because it has to fulfill the specifications of our plants, and therefore we need a cleaning up, and that's something of our IP, how we can do that. And then the material is used in our plants to make them virgin-like material, and our customers can have then a drop-in solution without any compromise on the technical. The next slide, please. So no doubt, sometimes we are asked, how are the CO2 emissions as we are dealing with high temperature? Does they need a lot of energy and emit CO2? We made a life cycle assessment, which was checked by 3 independent experts with a critical review, and it stated clearly that we save more than 50% of the CO2 emissions compared to the incineration of the plastic. And that, no doubt, can then also be allocated then to the materials which are made out of that plastic, so that we have a lower carbon footprint for the ChemCycling plastic compared with conventional plastic. So next slide, please. Some new business models. We have, again, a small startup, which was a startup coming out of BASF. It's called Dynamics. And there they have built now a portable near infrared spectroscopy solution, where you just you have to press just the green button here, and then with Bluetooth you can see then on your smartphone which type of plastic that is. That helps a lot for sorting. That helps a lot of keeping something separate, so that you can sell it a little bit more expensive if you have separated your different types of waste. And if it's a monoplastic waste, you get higher prices for that. So therefore, that's a really portable device, and I have seen it recently. Really impressive. Just press a button, and within seconds, you see on your smartphone what type of plastic that is. That can improve the recycling and the recyclability, no doubt about it. Next thing is, and we are working also together with another startup, which is called Security Matters, and they are using tracers, where you can put then tracers in the plastic in a very, very small amount, only ppms, and later on you can show and can see the whole supply chain, the whole value chain of that material, and you can really detect where it comes from. And that's especially important when you go for chemical recycling material, that later on you can show that that's really chemical recycling material, because the technical performance is exactly the same. You can differentiate it, but with some additive, for example, you can do that. And that helps for new business models. So my last slide for the packaging. I hope that I could have shown you that we go for the real whole life cycle. We have to look at the production and the processing, where we can replace then fossil with alternative materials. We have some products like water-based inks, which help later on the recycling of the material, the plastic material. We have a calculation of carbon footprint. So for all our products, you can get a carbon footprint for that one, and also for those one who have a reduced carbon footprint due to bio-based materials or to recycled materials. Again, a big topic is the use phase for packaging, which has to be covered because you know that with a low amount of packaging, you are saving a big amount of food, and we have to design that for sustainability, which includes also the food safety, the longer life shelf, less food wastes, and so on. That is also an important part of circular economy, and not only the end of life, but no doubt we also have to tackle the end of life issue. So therefore we help the customers for better sorting. We have mechanical recycling, we have chemical recycling, and we have organic recycling with some biodegradable plastics. So as BASF, we want to tackle the whole life cycle, and it's not so easy that we can say there's one solution that covers everything. We need a lot of solutions. We have a lot of topics, and each challenge needs a special solution. And there, no doubt, we are the preferred partner to help you to find the best solution for that.
BASF. We create chemistry.